So we'll start our discussion of plotting by looking at scatter plots. And before we do, we want to import baby pandas and import NumPy as usual. Now you'll also notice here that I'm importing a library called matplotlib. Matplotlib is a plotting library for Python, perhaps the most common plotting library. What I'm doing here is I'm importing it, giving it a special name, PLT, and then I'm saying let's use a certain style, a certain visual style, or a theme. This one is 538. It's meant to look like the plots produced by the popular website 538. So it turns out we're not really going to learn how to use matplotlib directly in this class. What happens is that baby pandas and pandas uses matplotlib behind the scenes. So it calls matplotlib for us, so we never really actually have to call matplotlib in this class at least. Just letting you know that this library exists, even though we're not really going to talk about it too much. All right, scatter plots. So here's a new data set. We're going to get a CSV file full of actor information. It'll have these columns. So we'll have the name of an actor, the total gross, meaning the total amount of money that their movies have produced, not just how much money the actor has produced, but how much money the movies have brought in, the number of movies they've been in, the average gross of one of their movies, their top grossing movie, and then the gross of their top grossing movie. So let's read it in. Remember, we have this method read CSV. So we'll read in actor CSV, and we're going to set the index to be the actor name. So here's what it looks like. So we see, for instance, Harrison Ford. His movies have made $4.87 billion. He's made 41 movies, and so forth. Okay, so let's ask a question. What's the relationship between number of movies and the total gross? Okay, the number of movies and the total gross. So before we plot this, it's useful to think about what we might see. Okay, as someone is in more movies, okay, what do you think happens to the total gross of the movies that they're in? Right? If you're in more movies, the movies are going to just sum up. Right? You're summing up the gross of all of these movies, so it's going to be a larger number. It makes sense to plot this in the following way. We're going to plot it with a scatter plot. What we'll see here is that on the x-axis is the number of movies, on the y-axis is the total gross of all of the movies, and you can kind of see that there's a trend. As the number of movies increases, the total gross increases, roughly. It's not like a straight line or anything like that, but you see that there's this sort of overall trend. Now, how did we actually produce this visualization? Well, we used the plot method. So we took our table, actors, we called .plot, and here's how we called it. First, we said, here's the kind of plot we want to make. So we used a keyword argument. We said kind equals scatter. So you have to tell Python kind, you can't change this word, it has to be kind, equals, and then we tell it it's a scatter plot. Now, down the road, we're going to be making bar charts and things like that, and we'll change scatter to the appropriate term then. Okay, so we then said, what do I want to plot? Well, on the x-axis, I want to use the number of movies. This was the column title. If we go back and take a look at the table, we had number of movies here. So I was saying I want to use this column as the x-axis, and as the y-axis, I want to use the total gross. So that's what I see here. So I say kind equals scatter, x equals this, y equals this. Okay, when you're using plot, you want to include the keyword argument names here. Kind equals scatter, x equals, and y equals. So that produces this visualization right here. So here's a quick reference for the scatter plot method. The scatter plot is useful for visualizing the relationship between two numerical variables. Notice here I had on one hand the total number of movies that an actor has been in, that's a numerical variable, and on the other hand I had the total gross, that's a numerical. So I'm visualizing how one numerical variable changes with the other. What you get here is 1 point in the plot per row of your table. So if we go back and take a look, if you were to count all of these up, all of these dots, you would find 50 dots. That's because there are 50 rows in this table. Each row gives us a dot in the plot. Okay, so what's the relationship between the number of movies and the average amount of money they've made per movie? Now, again, before you make the plot, it's useful to think about what you might see. Okay. Now, before I was plotting number of movies and just the total amount that they've made. And of course, that's going to increase with the more movies you've made. But think about actors who tend to be in a lot of movies. Okay. Not all of them can be blockbusters. Some of them are pretty bad movies, right? So if they're in a bad movie, that brings down their average. Let's take a look and see if that's true. So here's what we kind of observe. The more movies that someone is in, the less a movie tends to make on average. And this is kind of what we'd expect. If somebody is in a small amount of movies, it might mean that they pick and choose the good movies to be in. On the other hand, if they're in a large number of movies, it might mean that they'll just be in any movie, and a lot of those movies are bad. Notice how we've called this plot method. We've said let's scatter. Let's use kind equals scatter. X-axis is number of movies. Y-axis is average per movie. That's the column title. So there are a couple of interesting things about this plot. First of all, there's a negative association. What that means is as the number of movies increases, the average per movie actually decreases. Okay. If the association were positive, it would be the other way around. As X increases, Y would increase as well. But more interestingly, there's this outlier here. Somebody here is making fewer than 10 movies. Okay, but their average per movie is huge, something like $450, $500 million. So let's take a look at that. So first of all, let's take a look at that first sort of interesting thing. We notice that as people make more movies, their average decreases. And we kind of rationalize this by saying if you're in a lot of movies, they're not all great movies. You might just be willing to be in any movie just to get paid. So let's take a look at the actors for which the number of movies is greater than 60. Going back to our plot here, that's going to be these actors. Okay, who are these dots? We can do that by using the selections that we learned about last time, or queries. So I'm going to get the number of movies column. I'm going to make a Boolean series by comparing that to 60. So I'm asking which rows have number of movies greater than 60. And then I pass that back into actors using the square brackets. Here's what I get. Now these are 4 really great actors. However, they are also in a lot of bad movies. You can look up on IMDb and see some of the bad movies they've been in. They've been in a lot of good movies, but just the sheer number of movies that they're in tends to water down the average gross per movie. So that's an interesting result. But let's take a look at the outlier. So remember that person, going back a few slides here, who made fewer than 10 movies, and each movie, or on average, the movies that they were in made something like $450 million. Who was that person? Well, we can do that by using selection again, by using queries. Okay, this time I'm going to get all of the actors whose number of movies is less than 10. And I see the actor is Anthony Daniels. They've been in 7 movies, which is not a lot for this data set. And each movie, or on average, the movies made $451.8 million. Now their top movie was Star Wars: The Force Awakens. So, can you guess who Anthony Daniels is? You might not have heard of them, but you might have seen them. This is Anthony Daniels. He's the guy who played C-3PO. So he didn't have a major role in these movies. Remember, what we're looking at is not how much money the actors made. It's how much money the movies made that the actors were in.